So who can read for me that?
Scientific notation.
Oh, that's good. Scientific notation. So this is what we are going to study about. Scientific notation. Okay, we will get to understand it very well as we continue. Now, look at this table. Can you see it?
Yeah.
Okay. Now, we can see in number 1, anyone who can read for me number 1?
Thailand population in 2017.
Okay. What was Thailand's population in 2017? Can you read that number?
Billion, 69 billion. Okay, I can read it for real.
Yes. Mm.
69,100,000.
Perfect. 69,100,000. Tana, can you understand that now?
Yes.
69,100,000 people. So this means that in Thailand, in the year 2017, there were 69,100,000 people. Wow, this is such a big number. Look, in scientific notation, we write it as, who can read it for me?
Distance between Earth and the Sun.
6.91 times 10 to the power of 7. Yes. Now, you see that when a number is big like this one, it's not easy to read. Even to write, it might not be easy. But when you write it in scientific notation, it becomes a bit easy. You look, this one is 69,100,000. But here it becomes 6.91 times 10 to the power of 7. Kind of looks a bit easier to say and to write. Okay, Wichasin, you can read number 2.
Okay. Distance between Earth and the Sun.
Okay, what is that distance? Can you read that number, or it is so big for you to read?
I don't know this one.
Okay, anyone else who can try this?
139,600,000.
Did you say 149 or you said 139?
149.
Okay, correct. That's good. 149,600,000 kilometers. So you can see that between Earth and Sun, we have a distance of 149,600,000 kilometers. Now, when we write this big number in scientific notation, it will be, who can read it for me? Yes?
1.496 times 10 to the power of 8.
Very good. Now, this number is very big, but when we write it in a scientific notation, it becomes a bit easier to read and to write. Okay, now we have finished 1 and 2. These numbers are integers, or like they are whole numbers. Look at number 3. Mass of a dust particle. Wow. Who can read for me this number?
0.00000000753.
You see, with very very many zeros. So what do you think about this number? Is it very big or very small? Is it a small number or it's a big number?
I think small number.
Yes, it is very, 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 very small. You see, when numbers are very, very, very small, it is also not easy to write them and to read them. So when you use scientific notation, it becomes a bit easier. So we will write it as 7.53 times 10 to the power of negative 10. Can you see that? Okay. Number 4, we have, who can read for me number 4? What is this? Yes, Tana, you can read this for me.
Okay.
Mhm.
Mass and oxygen atom.
Very good. Mass of an oxygen atom. Look at this number. It really takes too much time to read because it has got very many zeros. 0.000000000. You may even forget some zeros. But then when you write it in scientific notation, we have it as, anyone who can read for me? Okay.
2.656 times 10 to the power of negative 27.
Oh, yes. Thank you, Sophia. So now you can see that the number is so easy to read and write when we put it in scientific notation. But when it is just like a normal number, it's not easy. But now, from what we have seen from number 1 up to number 2, we see that number 1 and number 2, these are big numbers. When we write them in scientific notation, you can see here we have times 10 to the power of 7, and here times 10 to the power of 8. What can you see about the powers of 10 in number 1 and number 2? What can you say about the powers of 10? Say anything that you can see about powers of 10 here in number 1 and number 2.
Positive, right?
Very good, Richardson. Thank you. The powers are positive. The powers are positive. And you see that in number 1 and number 2, the numbers are very big. These numbers are very big and the powers are positive. Okay, now you look at number 3 and number 4. What can you say about the powers of 10 in number 3 and number 4?
Negative.
Negative.
Very good. The powers are negative. The powers are negative. Okay. But you can also see that in number 3 and number 4, the numbers are very small. Right? So, what do you think? To write numbers in scientific notation, when numbers are very big, the powers are positive. And when numbers are very small, the powers are negative. Is that okay?
Okay.
And also, we see that to write numbers in scientific notation, it is a very good practice because it makes very big numbers easier to read and write. And it also makes very small numbers easier to read and write. Okay, now I want to give you the way how numbers in scientific notation look like. A number in scientific notation, let's say that we have A times 10 to the power of n. So we must make sure that we write a number to be like A times 10 to the power of n, where A is more than or equal to 1. So this means that this number must be 1 or bigger than 1. But also, this number must be less than 10. So the number that we write here, it must be 1 and above, but also it must be smaller than 10. Then n must be an integer. When we say integer, I believe you know that we mean negatives, 0, and positives. So that is the rule. Number 1, A must be equal or bigger than 1. 2, A must be smaller than 10. Number 3, the power of 10, this n, must be an integer. So this means that if this power is a decimal, or if this power is a fraction, then that is not correct. It means that if this A is a number that is bigger than 10 or equal to 10, it means that it is not correct. Let's look at some examples. Okay, look at this table. Let's check number 1. In number 1, we have 4.5 times 10 to the power of 4. Do you think this is in scientific notation or not scientific notation? Yes, please. Anyone to answer? Can you hear me? Hello? So, Picha, can you hear me?
There were they.
Can you hear me?
Yes.
Okay. Do you look at number 1 where I have put a red line? This number, you think is in scientific notation or not scientific notation? Or you are not sure?
I'm not sure.
Okay. Remember we said that a number in scientific notation must be like A times 10 to the power of n. Now, we said that this A should be 1 and above, but must be less than 10. Now, if we have 4.5, you see 4.5 is bigger than 1, which is good, and it is smaller than 10. That's okay. And you look at the power of 10, it is an integer. You said that this n should be an integer. So this is okay. It is in scientific notation. You understand that?
Yes.
But now look at this one. This number is 45. Do you think this number is in scientific notation or not?
No.
Why?
Because 45 is more than 10.
Very good. Because 45 is more than 10. So this is not in scientific notation. Look at number 2. We have 2.06 times 10 to the power of 8. Look at 2.6. Is it bigger than 1? Yes or no? Yes?
Yes. Right.
Okay. And it is bigger than 1, and also it is smaller than 10. Look at the power is 8. Is 8 an integer or not an integer?
It's integers.
So it is correct. This is in scientific notation. Good. Look at this one. 0.206. Is it bigger than 1 or smaller than 1?
Smaller than 1.
Smaller than 1.
So is this number in scientific notation or not in scientific notation? Yes?
No.
No.
No. Because scientific notation, a number should be 1 or bigger than 1, but it must also be smaller than 10. Okay, look at number 3. Is this in scientific notation or not in scientific notation? Yes?
Scientific notation.
Why?
Because 3.71 is more than 1, but it's not less. Yes, it's more than 1, but it's not more than 10.
Yes, very good. And also 21 is
Integer.
an integer. Very good. Okay, we look at this. Do you think this one is in scientific notation or not?
No.
No.
Why? Why?
Because the power is not an integer.
The power is decimal, right?
Yes.
It is 21.2. Yes. No. Okay. Number 4. Anyone else apart from Wichasin? I think Wichasin has understood. I want someone else to answer. Number 4, is it integer or not? Sorry, is it scientific notation or not scientific notation? Yes? Hello. Tana, can you hear me?
Yes.
So is this scientific notation or not scientific notation? Number 4.
Again, yeah, the other noise loud.
Yes, number 4. This one. Is it in scientific notation or not in scientific notation?
Yes, I think it right.
Why?
Because it's the is has the correct correct that some kind of that.
Okay, so because you see 8 is bigger than 1 and it is
Okay.
smaller than 10. And you see the power of 10 is -3 and -3 is integer. Correct. And what about this one? Is it in scientific notation or not scientific notation?
It's not.
Why?
It's big. Is not bigger than 10. Is small. Is more than 10 is correct, but the the in the power of 10 is not is not the correct.
Yes, the power of 10 is not integer, right?
Yes,
What is it? Is it decimal or fraction?
it's the fraction.
Very good, very good. Okay, someone else, not Tana, not Wichasin. Number 5. What do you think about this? Is it scientific notation or not scientific notation?
Is scientific notation.
Why?
because 9.25 more than 1. And but 9.25
is smaller than 10, right?
yes.
Then about the power of 10? The power of 10 is integer, right? Yes, so Picha, can you hear me?
Yes.
Okay, the power of 10 is integer, so it is correct. So, Picha, tell me about this. 9.25 times 10 to the power of negative 1.01. Is it scientific notation or not?
It's not.
Why?
Because power of 10 is not integers.
What is it?
It is decimals.
Very good, very good, very good. I like your answer. And number 6, I will ask Jirapat. Jirapat, can you hear me?
Yes.
Okay, so number 6, is it scientific notation or not?
Yes.
Okay, why? Why? Jirapat, I cannot hear you. Can I ask Poptam? Poptam, can you hear me? Poptam does not hear me. Okay, number 6 is, this one is scientific notation because 1.0 is equal to 1. That is okay. And the power of 10 is integer. We have got negative 1. Sorry, we have got negative 16, which is okay. But this one is not, because we have 10. 10 is equal to 10. We must have a number that is less than 10. So that's why this is not scientific notation. Do you understand?
Yes.
Okay. Let us have an example, like the correct example, number 1. Let's say that express each of the following numbers in scientific notation. Okay, let's have number 1 as 149,600,000. Let's have number 2 as 0.000038. And let's have number 3 as 476. And let's have number 4 as 0.021. Okay, can you all hear me?
Yes.
Okay, now let's get the solutions. You know that the rule is that the number A times 10 to the power of n. We know that a must be equal or more than 1, but less than 10. We know that n must be an integer, no problem. Whether positive integer, whether negative integer, whether 0, no problem. But it is integer. When it is fraction, not correct. When it is decimal, not correct. Okay, now let's go ahead and answer number 1. We have 149,600,000. Okay, so this number is so big. It is so big that it is bigger than even 1. And we need this number to be less than 10. So this number is bigger than 10. So we need to make it small. So what we do, we assume that we have a decimal point here. Are you okay? Can you hear me?
Yes.
Now,
Yes.
if a decimal point is here, we will move until we get a number that is smaller than 10 and bigger than 1. Okay, we move. Okay, when I bring it here, the number is still big. When I bring it here, the number is still big. When I bring it here, the number is still big. When I bring the decimal here, still the number is big. When I bring it here, can I put a point here? The number will be less than 10 or still it is bigger than 10? You see that it is still bigger than 10. Move and bring here. This, you remain with 149. 149 is bigger than 10. You bring it here, you remain with 14. Is 14 bigger than 10 or less than 10?
More than
Is
10.
more than 10.
More than 10. Okay, so we have to move again. We bring it here, we remain with 1. Is 1 less than 10 or bigger than 10? Yes?
Is less than 10 now.
Is less than 10.
Yes, now that is very good because it is less than 10. So we can bring a decimal point here. Now, when we put a decimal point here, it means that we have 1.496. The 0 we don't need to write, okay? Times 10, what is the power? The power should be the number of digits that we skipped. We can count 1, 2, 3, 4, 5, 6, 7, 8. So it will be to the power of 8. You see that? Understood?
Yes.
Yes.
Okay. So when we write number 1 in scientific notation, we get 1.496 times 10 to the power of 8. Now, when we move the point from right to left, when we go to the left, the power is positive. But when we go to the right, the power is negative. You understand that?
Yes.
Now, the power is positive because we are going to the left. When we go to the right, the power will be negative. So we have 0.00038. So in order to make this number be less than 10 or okay and bigger than 1, do we need to move this decimal point to the right or to the left?
To the right.
To the right.
To the right. We must go to the right because when we go to the left, we don't have any numbers there. We only have 0. So we have to go to the right. So let's move and counting. 1, 2, 3, 4. We cannot put it here because still we are going to have 0. So we bring it here such that we get 3.8. And it's very good that 3.8 is less than 10 and bigger than 1. So we have our answer as 3.8 times 10. We are very sure that the power will be negative because we are moving to the right. So what is the power? What power can I write?
Negative 5.
Negative 5
Negative 5. Why?
because it's go to right side.
And we moved 5 steps, right?
Yes.
Yes, because you have 1, 2, 3, 4, and 5. So that becomes our answer. Okay. And now let's do number 3. We have 476. Is that number bigger than 10 or less than 10?
Is bigger than 10.
Greater than 10.
So to make it get into scientific notation, what should we do? How can it be? What should I write in scientific notation? Yes, please. What should I write?
Is
4.76
Mhm.
times
times
10
10
to the power of 2.
To the power of 2. Very good. This is because we are going to have our point here and we can move it 1. We cannot put it here because we are going to get 47 and 47 is bigger than 10. So we have to move again. We come here, we have 4. 4 is smaller than 10 and bigger than 1, which is good. So we get 4.76 times 10 to the power of 2. Perfect. Have you understood, all of you?
Yes.
Yes.
Okay. Now we get to answer number 4. Number 4, we have 0.021. So what is it in scientific notation? Yes, please.
2.1.
Yes, please. So Picha, go ahead.
Times 10 to the power of 2, right?
Negative or positive?
Negative.
Okay. Negative 2. Which is in, do you think Supicha is correct?
Yes.
Not sure.
Yes, you need to be sure. You see, if a point is here, of course, we cannot go to the left. We must go to the right. So you count 1, 2. You put it here. You get 2.1 times 10 to the power of 1, 2. 2. And if you go to the right, the power is negative. So, Supicha, you are correct. Okay?
Okay.
Okay. So, I want to give this to someone else. Let me give it to Kanokpon. Kanokpon, can you hear me? No. Teacher, can you hear me? Navapon, can you hear me? Oh, what happened? Pichayapa, can you hear me? Oh, only 3 people can hear me. Jirapat, can you hear me?
Yes.
Okay, try this for me. we have got 5, 3, 0, 0, 0, 0, and another 0. You're apart. Let's go write this in scientific notation. What should I write? Yes, you're apart. What should I write? Look, put a decimal point here. Move 1, 2, 3, 4, 5. When we put here, we get 5.3. So we get 5.3 times 10. We are going to the left. The power is positive. 1, 2, 3, 4, 5, 6 to the power of 6. Is it okay? Do you understand? Okay. And now I'll give you the last one. 0.000048. Okay. This one we cannot go to the right. Sorry, we cannot go to the left because we only have 0 going to the left. So from this point, we must go to the right. We move, we move, we move, we move. When we come here, we will get 4, which is okay. 4 is more than 1 and less than 10. So, and the whole of it will be 4.8. So it is 4.8 times 10. We are going to the right, the power must be negative. So 1, 2, 3, 4, 5. Is it okay?
Okay.
Okay, very good. Now, something that I will ask you is kind of very easy. Express each of the following as an integer all decimal. Okay, we are having 1.325 times 10 to the power of 6. Now, this number is in scientific notation, but now we want to write it as an ordinary number, as like an integer, as like a number that is not in scientific notation. We're not sure, it may be an integer or it can be a decimal, but we just want to write it as a number that is not in scientific notation. And another example, we get 4.4 times 10 to the power of negative 3. So we need to write it like we get it away from scientific notation. So I'll do this for you, number one. If we have 1.325, it means that we have 1,325 out of, if you write it as a fraction, out of 1,000, right?
Yes.
Yes.
And 10 to the power of 6 means that I have 10 times 10 times 10 times 10 times 10 times 10, 6 times 1, 2, 3, 4, 5, 6. You get it?
Yes.
Yes.
And this 0 we can cancel it with this 0. This 0 can go with this one. This one can go with this one. And we remain with 1, 3, 2, 5. How many zeros do we have? 1, 2, 3. 1, 2, 3. Finished. This is our number. Do you understand?
Yes.
Yes.
This is very, very easy. Okay, we look at number 2. If we have 4.4 times 10 to the power of negative 3, what is 4.4 as a fraction?
10.
Yes, 44 out of 10. If we have 10 to the power of negative 3, it means that we have 1 out of 10 times 10 times 10. You understand that? Negative power. Yes. So this means that we have 44 out of
10.
10,000, right? 10 times 10 times 10 times 10. Okay, now write this as a decimal. 44 out of 10,000 as a decimal. Let's go. 0 point.
0.
0.0044.
Yes, 0.0044. That is it. That is your number. Have you understood?
Yes.
Yes, so that's how we change the numbers from scientific notation back to integer or decimal. So I believe you have understood how to write numbers in scientific notation. Is it okay?
Okay.
Okay, that's good.